All right, here we are. We're going to talk about probability tree diagrams. It's still within the conditional probability section, as we were talking about. And these types of questions, you will recognize, at least you should recognize upon reading them, that they are dependent, okay? And most likely you will be asked to come up with some kind of visual representation of the scenario. Tree diagrams are one of those, okay? And that's what I'm going to use. So let's see here. A janitor at a high school believes that if he forgets to place a slippery or caution slippery sign, or slippery when wet, whatever you want to call it, but when he forgets to place the sign after mopping, that there's a 60% chance of someone falling. I think we can probably wrap our heads around that, right? There's a higher chance of someone falling if that sign is not placed. If he remembers to place the sign, there's a 22% chance of someone falling, slipping and falling, right? And then it adds, there's an 83% chance that the sign will be placed, right? So I think A asks for draw a tree diagram showing all possible scenarios. And we're talking probability here. There are percentages at play here, so keep that in mind when you're about to answer one of these, okay? So the sign is, like, one thing to remember is that something has to precede or has to happen first. It's going to be apparent within the question. So placing or not placing the sign is what happens first, okay? So you can, right, you can put, branch it out like this. And so you can call this, putting up the sign, not putting up the sign, right? And so we would say that the chance of placing it, right, placing the sign is 83%. You can go 0.83, you can go 83%. It's really up to you how you want to do that, okay? If they give us that this is 0.83%, then we know we just subtract that from 1 to figure out the probability of not placing the sign, right? So we go 1 minus 0.83 is 0.17, right? So I will use a red pen for that part. So, right, you should always check, does it add up to 1? Okay, so this is just the work here. It adds up to 1. And then we see what happens next. So under each circumstances, there is falling or not falling, right? So falling, not falling. Same here. All right. So here you have to be careful. If he forgets to place the sign, that's the first info that we're given. If he forgets to place the sign, there's a 60% chance of falling, okay? So you have to be like, okay, if I were to go down this branch, which is forgetting to place the sign, there's a 60% chance of falling. Okay, so I will highlight that. If he forgets to place the sign, there's a 60% chance of falling. So that's how this came to be there. Okay, and then I automatically should know, okay, if this is 0.6, then this is, because they're not going to give you all the information. Sorry, this is supposed to be not falling, right? Just make sure you get that right. 60%, if the sign is not placed, which is down this branch, then there's a 60% chance of falling, therefore a 40% chance of not falling. Okay. If he remembers to place the sign, there's a 22% chance of someone falling. Okay. So remembering to place the sign, there's a 22% chance of someone falling. So we would just go, okay, so we put the sign up, there's a 0.22 chance of falling, and therefore a 0.78 chance of not falling, right? So this is how we've filled in. So all the red is basically the complement. Remember that from chapter 3? The complement of falling is not falling, which is 0.78. Complement of falling here, which is 60%. Sorry, the complement of falling here would be 40%, and so forth. So I always find the other part. And I would find it extremely helpful to actually not just calculate the percentages or the probabilities, but also to have proper notation here. So if this one would be probability of the sign being up and falling. So remember, it's always multiplying. That's 0.83 times 0.22. Okay, come up with that. Sorry, keep it straight here. This one is probability of sign up and not falling. That's 0.83 times 0.78. And then we go down this branch, probability of the sign not being placed and falling. That's 0.17 times 0.6. And last is probability of the sign not being up and not falling. Okay. So here we go. And calculate that, and I already did that, so I'm just going to spare you the details. So that's 0.1826, 0.6474, 0.102, and this is 0.068. Okay. A quick check at the end here. It should add up to 1. And I did check that, so I can tell you that that is right. Okay. So there's your tree diagram with all the probabilities laid out. So I just want you to understand here, if the question said, okay, what's the probability of falling, just in general falling, you would be looking for all the F's, right? There's an F here, there's an F there. So it could be this scenario or that scenario, right? So you'd add up. If it said, you know, what's the probability that the sign just won't be up at all, you add up these two here. Okay, so keep that in mind. You gotta, this is the whole sample space here of what could happen. Okay, so remember, there are two events and they're dependent. We know that they're dependent because of the wording, right? It's kind of saying if the sign is up, the probability is something. The probability of falling is 0.22. If it's not up, it's higher. So right there, that should give it away. It's like, hey, these are dependent here because, right, the probability of that second event changes based on what path you go down. Okay, so if the numbers change, right, between falling, it's not the same, then you know, oh, these are dependent events. Okay, so I hope that makes sense. What's the probability of someone falling? So basically, they're asking for probability of F. I'm going to use maybe a pink highlighter here. So I'm going to go probability of F. I'm going to go up here and just highlight, there's one here. This would involve falling, right? Same up here. This would involve falling. One where the sign is up, one where it's down, but you got to consider both of them under your entire sample space. So we would go 0.1826 plus 0.102. And that would be a total of 0.2846, that's acceptable, or you could say 28.46%. Either one would be fine. C. What is the probability of having placed a sign given that someone fell? And here, I'm going to have to use a different highlighter yet. This should ring a bell. Oops, sorry, here, the given here. We're going to use a bar in our notation to make reference to that. Okay, so let's see here. What is the question asking me? Okay, well, let's translate that. What's the probability of having placed a sign, okay, given that someone fell? That's what it's asking for there. And I don't know if you remember just before this, the pages before this, if you have something like this, you should think, oh, okay, so we're comparing S and F here. And we know this is a dependent probability situation. So we would go, well, probability of S and F or F and S, it doesn't really matter. It doesn't matter, it's the and that matters. Would be this part here usually comes second, right? Probability of S given that F happened. So that means that what would go in here in our formula? What already happened? This part happened. So I almost place this here and I go backwards and I say, well, that must mean that the probability of falling, right, needs to happen first. This is the first event that I'm after. And this is the second event, which is the probability of the sign being up or not, given that somebody fell. So I know it's a little bit like the wording, but maybe just remember, given, like try to translate the statement into proper notation. Then remember, oh, it's S and F. It's the probability of both of them happening. And then obviously this part of the notation would always go second. And then just ask yourself, like, what is over here based on the translation? Oh, it's falling. Well, that is what needs to come first. So I will flip back a little bit here to show you. Probably make it a little longer. But it goes back to this kind of reasoning. We did this on 35. I'm going to go even further back. So when it's independent, when the one event doesn't affect the next one, we just write it as usual. Event A times probability of event B, or vice versa. We can flip them. But when we know it's dependent, we got to use one of these two notations. I tend to just stick with this template here. But remember, whatever letter is there, that's the probability that you want to find first or have first here. Okay, so let's go back. I will assign 38 to you. I will also make a video. So if you want to pause it after this is done, you go try that. Okay, let's fill this in with numbers. Probability of S and F. Where is that? Because you got to have numbers here. S and F is already up here. It's 0.1826. I leave it as a decimal. 0.1826. Probability of falling. Well, I happened to already ask. I asked that already before. I just happened to do that, right? If not, you would have had to just realize, oh, it's right there. So I'm going to highlight that with pink as well. So we already know what that is. That's 0.2846. And this is our unknown, this one. We're going to figure that out just now. Okay. So what do we need to do? We need to divide both sides by 0.2846. So this C is not all that popular, but hey, it could be worth 2 marks. So you want to make sure you know how to do it. And I try to walk you through that. So probability, this probability here, because they can ask you anything once you have this tree diagram. You divide these two, you get 0.6416. Okay, so that would be good enough, or 64.16%. It's up to you how you want to state it. Okay. D, what is it asking? I'm going to do D here. What is the probability of not having placed a sign given that someone fell? That is what D is asking here. Given. There's that word given again. It could be provided that someone fell, or us knowing that someone fell, but given is also a classic. It's probably the key word that you need to remember. And I will go back here in our notes and just make sure that that's what the given stands for. Okay, let's see if we can translate this. What are they asking for? They're asking me for probability of not having placed a sign given that someone fell. That's what they're asking for. Okay, so you have to be a bit, you have to play detective here. Well, it's not having the sign up and falling is what we're comparing, those two events happening at the same time. Well, it would be like this. Those two events happening at the same time. This part has to come back here because it's what happens next, right? So given that F is over here, I'm going to say, well, that means that I need to figure out the probability of falling again. Okay. So there it is. Falling is right there. Already know that number. But what about this one? Probability of not having the sign and falling? Where is that? We have our probability of not having a sign up and falling is actually this, 0.102. Probability of falling, if I didn't already calculate that before, you would just go look for all the instances where there is a fall involved. And so that's 0.2846. And we multiply that by a probability of this. Divide that out. And that gives me, do that because I added that to your notes. That's 0.3584 if you round it. Okay. Maybe I will just take a brief moment here to explain this. What are we calculating here? Okay. You are basically finding out in C, for example, what's the probability of the sign being up given that someone fell? You're basically asking, hey, like if we know that someone fell, like given that someone fell, like we already know that that happened, what would it be randomly, like what are the random chances that the sign was actually up? That's what you're asking here. So, right, you hear someone fall or you see someone fall, right? It's like, oh no, somebody fell, right? We know what the probability is based on this tree diagram. So we did some backwards calculation. If someone falls, there's about a close, right, 64% chance that the sign was actually up. based on the information that we're given. That's what you're finding out. Okay, just in general. This circumstance here, you're asking, right? Well, if somebody fell, right, just randomly, you see someone falling, you're just wondering, wait a minute, like, what are the chances that the sign wasn't up? Okay. And the answer is 35.84%. And coincident, like, it's not coincidence, but we know that, right, that the sign was up and that the sign wasn't up, they add up to 100%, right? So it's not just simply when you have one of those given questions, it's not just simply going to be grab a number from my tree diagram and answer it. You're going to have to do some calculating like we did here, okay? You can pause now and try 38. I will do it. See if you can. If you're stuck, you just press play and you watch me solve it. Okay. There you go. The Savannah soccer team is playing a game tomorrow. Based on the team's record, there's a 50% chance of winning on rainy days and a 60% chance of winning on sunny days. So you know that this is dependent because the chances of winning change based on whether or not it's raining. Okay? Tomorrow there's a 30% chance of rain, and the league does not allow ties. So somebody has to win. So there's no ties, right? Win, lose. Determine the probability of Savannah's team winning tomorrow. It's just basically one's probability of W. What is that? Determine the probability that her team will lose tomorrow. So it's probability of losing. That's it. So you can't just answer this because you can't just take losing. Oh yeah, we know how that goes. It's like 50% chance of losing, 40% chance of losing. Like you can't just answer it based on what's here because you have to consider all possibilities. So what happens first? What determines whether your chances of losing are higher or lower? It is raining or not raining. So this would be raining, this would be not raining, or sunny days. Okay. So raining, according to this, is a 30% chance of it raining tomorrow, which means there's a 0.7 complement, right, of it not raining. All right. So after that happened, you can win or lose, win or lose. Okay. We're told that if it is raining, there's a 50% chance of winning, which means there's a 50% chance of losing. I should probably, because that's not given. If it's not raining, if it's sunny, then there's a 60% chance of winning, which means there's a 40% chance of losing. Let's write it all out. Probability of rain and a win would be 0.3 times 0.5. Probability of rain and loss would be 0.3 times 0.5, exactly the same answer. Probability of not raining and win, 0.7 times 0.6. Probability of not raining and losing. We could have done win, not win, but hey, we have to be flexible. Okay, so figure out these probabilities. This is 0.15, 0.15, 0.42, 0.28. We can do a quick mental math here. That'd be 70 and another 30, that's 100. So we know this adds up to 1, which means we've done everything correctly, typed everything in correctly. Doesn't take long, but now you're on your way. Okay. So probability of winning, you would just go and add up everything that has a win in it. So it'd be 0.15 plus this has a win in it, 0.42. So that would be 57% chance, right? There you go. Then if you want B, probability of losing, I think we all know what that will be, right? It's the complement of this, it's 43%. But if you missed it, you just go 0.15 plus 0.28, which is 0.43 or 43%. So I don't think that surprised you a whole lot. How about I add a question here? I will add C to this. So just write this down. Here you go. What is the probability that it was a sunny day, comma, given that the team won? Yeah, sure. Could you calculate that? Take a moment, try that, try to translate that before you watch further. All right, so they're asking, this question is asking, hey, what's the probability that it was a sunny day? I should change the signage here. Sunny for us means not rain, correct? That's what we want. So I'm basing it on the letters I've used here. So you want the probability of it not having rained given that the team won. This is what the question is asking. Once you've determined that, you're like, oh, it's raining and winning. Sorry, not raining and winning. So probability of not raining and winning would be, well, there will be something here, but I'll write this part down because that's obviously what happens second. Okay, so you need to take the W here and let that go in here. So that happened first, winning happened first. Okay, so not raining and winning, let's go here. Not raining and winning, that's 0.42. So you plug that in here. Probability of winning, I'm going to have to do a bit more work because they didn't. Oh, I actually know that. That's here, 0.57. Sure. If not, I would have had to add up all the instances where there was a win, which is here and here, right? These two numbers. So that's 0.57 times that. So we divide both sides by 0.57. Cancel them out. And I have to do this because I made it up. And that's 0.7368. Okay. So if you just grab any random win, okay, we know that, right, that because that happened first. We know that there's a 73.68% chance that it wasn't raining that day, based on all the information we have, because we need to consider all of it. Okay. All right. So the next would be 39, and I would probably say 40 to 43. I'm going to post all the keys, and you can check. You can practice as much as you want and get really good at it. I would say 39. The answer is already here. The wording is very interesting, so you have to be very careful. So if this one throws you off, I just thought it's a good real life scenario. If you just want to dive right into these ones, you go for it. Page 40 is probably where I would recommend you go. And where is the given? You're gonna have to look for it. So they have some, just a deck of cards, so that's still all there. So I'll have to, you'll have to just make sure you read, and if they have one of those given situations, just make sure you you know what to do there, right? To translate that. Oh, I found it. Just thought I'd let you know. On page 43, page 10, determine probably that Jen gets the part given that she auditioned. So you're going to have to do your tree diagram, and then on the side, like with all your probabilities, and then on the side, actually translate that and then do the math. So I would strongly encourage you, if you want practice, that. Question 9 is also, right, lung cancer, given that she smokes. So 9 and 10 specifically deal with that. Good luck.